Okay. I spent over an hour designing this thing to be able to hold a bunch of fries. And it's pretty funny looking. It looks like the kind of thing, I don't know, it looks like a custom gaming PC case, you know, but it's gonna use a lot of filament because it just has so much surface area. And I realized there's a smarter way to go about this. So I'm gonna pretend this doesn't exist. And I'm going to make a sketch here, and I'm going to start over. So, I measured out the large fry cup. And it has a volume of approximately 30 cubic inches. I have a maximum height here of 4.5 inches. Which means that I have, if I pull up a calculator, 30 cubic inches divided by 4.5 inches is I have to have an area on the bottom of at least 6 2/3 square inches. And what I didn't like about this was the amount of filament it would use. And the reason it would use a lot of filament is because it has a lot of surface area. So I'm going to start with a circle. And another thing I realized, it doesn't have to be, it doesn't necessarily have to be all the way inside of the tongs. I put the circle wherever I want. So, and of course I'm going to use a circle as the starting point because the circle has the most area with the least perimeter, which means it'll give me the most volume out of a 4.5 inch tall extrusion with the least surface area. I'm going to put a line going from this to the circle and another line going to the end of the circle. And then I'm going to dimension this as 6.667 divided by, oh crap, I forget how to write pi. It's not pi. It's not capital Pi. Oh, is it capital Pi? Inches. Okay. Well, 2.122. So I'm just gonna rename that as 2.122 inches. There. And that'll give me the volume of a large. And that is so much smaller. Holy smokes. I love it. I love it already. But that's not all. That's not all. Because I need to put a scoop shape on it. So what I'm going to do, I'm going to go ahead and offset this by 2.4 for the walls. And put like a scoop here. And put these 0.8 apart. Make it as close as I can, as close as I reasonably can get to horizontal. Put this circle about here. And then make a line that goes, we'll put a line somewhere on this line. And I'm gonna put it about 60. The reason I want it to be about 60, well actually I don't want it to be about 60. I'd prefer for it to be about 53. Or even 50. Yeah. And how big is that? 18.522. That's already better. That's already better. What if I make this tangent to this one, and then this tangent to this one? Okay. And then I'm gonna go ahead and put a line wherever these are and measure it. Just to see how far apart they are, and they are about 2.4. Okay, so it's gonna be pretty slim here. But boy, do I already like how this is going. I can't believe I was so stupid before. Look at the sketch I had earlier. Nope. This sketch. Look at how much more that is. Alright. 53.899 times pi. I gotta make sure. I gotta double check. 53.899 times pi is... No, wait, pi is that. And if I convert that into square inches, area, square millimeter, hectare, square meter, decimal, mile, acre. What? Where's the square inch? It's way in. Okay, square inch. And I've got 169.32. .2. Okay, so that's wrong. That's wrong. I need 6 square inches. I'm just going to divide that by pi. 4.258 divided by pi. Hang on, let me see this other sketch earlier. This one. Yeah, so this is... Let's make this Let's go from length. Millimeter. Inch, 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 inch. 56, yeah. That should give me... Oh, that was also... This was also way bigger than it needed to be. That's also true. Anyways, this should be approximately correct. So I'm going to move this to about... Where do I like it? That's too far. Here is good. This was also way bigger because this was about the full size. And this only needs to be about half the size. This is half of what it needs to be. Or this needs to be half of the total volume, and then this is a little more volume on top of that, so that's going to be nice. Uh-oh, uh-oh, uh-oh. I would prefer for this to be parallel to this, and that brings that way the heck down, but it also makes it perpendicular to that, and that's incorrect. And the fact that it can do that means something. I'm going to instead, I'm going to instead make this coincident with this point. .65, 2.65, 15. Now I should be able to still move this and get... That looks good. If I delete the coincident, I can't delete the coincident. Oh well. There it is. 1/4 millimeter. Quarter millimeter. 1/4 millimeter. That goes in there just a little bit, and it's 2. That's fine. Alright, so now if I extrude this much, and this much, 2 sides, distance 1 is 2.65, distance 2 is... I'm just going to convert 4.5 to, okay, 114.3. $91.65. All right. It was that simple. And that should have plenty of space to hold a large worth of fries. It was always that simple. And this other thing that I want to pretend doesn't exist is entirely too complicated. And I saved a crap load of filament just on that. And just to be absolutely sure, I'm gonna do this. I'm gonna make a sketch on this plane. I should be able to project the get rid of that sketch and that one and that plane. And I should be able to project the outermost corners here. And put a rectangle on it. Okay, the outermost lines then. The object you are creating is not visible. Please toggle visibility in the browser. What? There. What do you mean it's not visible? Oh, that's why. Alright, and then if I just all join, I can measure its volume. And then I need to create another shape that's going to approximate the shape of the fry cup. And I'm going to do that in a new... Actually, no, I'm going to do that in this. I'm going to do that here. I'm going to put that on the origin. I need a rectangle that is about 48 by 42. I'm gonna make a plane coming off of this that is 127 tall. I'm gonna make a circle here on this plane that has a diameter of 87. I'm going to loft them, and then I'm going to go to this body, and I'm going to rename it Fry Cup, and I'm going to check its properties, and it has 4.859 times 10 to the 5 cubic millimeters. So if I take that 4859 divided by 2 is 2429. So if I take this one and I check its properties, it has 1.68 times 10. Okay, so it's a little too small. It's a little too small. It's too small by 1688. 741 of these units. Okay. So, go back into, let's suppress this. I'm going to go ahead and take this sketch, and here's the beauty of this. I can make this whatever size I want. If I make it about 70, right? Okay. Oh, this doesn't connect anymore. There. And then I unsuppress this. Now what's its volume? 2357. If I go into, oh, I closed the calculator. Gosh darn it. No, it's 3. Okay, it's 3. 3 times 10 to the 5. That's good. That's good. That's exactly correct. Or it's not exactly correct, but it's good. And it has a little bit of wiggle room to cut out some of this stuff. Let me go back to this sketch though, because I've realized that's gotten pretty long. I'd rather bring it in some. So I'm going to make this 75 and bring this back in a bit. Actually, as long as it's as long as this is that, and it connects with that, that's fine. Right, this is too long. This is good. This is good. Okay. Now if I unsuppress this again and I check its volume, 3.5, that's even better because I need to cut off some stuff. But I don't like the shape of it. I don't know why, I just don't like the shape of it. I'm gonna bring it inwards some. Now what is it? .16. Okay, that's pretty good. That's pretty good. I'm gonna keep it like that. Okay, now I'm gonna take these plane 6 and plane 11. Yeah. Okay. I'm going to make a sketch on plane 6. I'm going to put a circle here. Offset it by 2.4. I'm going to put a line going all the way to this point. Put a line from here to here, make it about 50. Put this circle here. And then this goes here. And then this circle does this have a measure? Oh, wait. Oh, I see. Okay. Delete that so that their relationship isn't... Okay, well then... Now I can make this circle tangent to here and offset it by 2.4. Put that there. And then make this tangent. Alright. Extrude this up to here. And then put a sketch. Nope. Put a sketch here. Project this circle again. Make it go all the way out. Then project all of this geometry. Then cut this down to this plane. Now if I make a sketch... Wrong plane. Why does it always... I don't like that. Put a sketch here. Put a line like here. And put a circle here because trim, delete, Okay, now could I... loft that into that. And that's still got a really, really thin piece, but... put a sketch here. Where's the what? Yeah, okay, that's unfortunate. Okay. And then any real ugliness on the outside? Not really. What is that on the inside? There's a piece here because I don't think I did the loft correctly. Yes, delete. Ah, it lofted into here. Where'd the project go? Lame. Well, that sucks. What if I do this whole thing into this whole thing? Yep, there we go. There's the geometry I need. Pretty much. Get rid of the sketch, get rid of the plane. There's no holes. Okay. So now if I actually put a sketch here. Then I extrude it all. Cannot extend extrusion to object. The extrusion profile falls outside the bound. Okay. Okie dokie. Make the sketch on this plane and just project all the geometry here. This. Put a line there. Put a line there. Put a line there. Alright, now what are the properties here? What is the volume? .06 times 10 to the 5. 2.06 times 10 to the 5 versus 4.86 times 10 to the 5. So that would be 2.43 times 10 to the 5. Close enough, honestly. Close enough. And like I could change this sketch. No, not that sketch. I could change where's this? Yeah, this sketch. Yeah. Okay, I could change this sketch to be something closer to like 60. Right? And now I can see what this is. .14. Doesn't change it enough. I'll just accept this as good enough. Because if I did this correctly, this is an overestimation of the volume, because I would have cut off a little bit here, but added a lot here, and then added a little bit here. And then there's also the fact that it's a diagonal line. So this should be an overestimation. So this should work. And if I compare it to this, it is much smaller and much better, much easier to get a grip on. Look, it fits inside of this one, so that's pretty good. I bring up the tongs, and I bring in the original sketch here. Whoops, that wasn't correct. I just wanted to see what the sketch was in the sketches. Sketch 80. Oh my goodness, I'm at 89 sketches. Two sides, 2.65, 22.65. Not there, but I mean, yes, technically, but minus 2.4. Not offset object. All right. See if I can chamfer these edges. Oh, hang on, hang on. There. Now let's see if I can chamfer these edges. Ten is too much. 9.9? No. 8, 7, 6, 5, 4. All right. And then another thing I'm gonna do, because I had difficulty removing the previous version of this. How do things get changed without me touching them? Another thing I'm gonna do, because the previous version of this gave me trouble removing the tongs, I had to cut them off. I had to melt them and cut them off. Luckily I didn't damage the tongs, but anyways, because that happened, what I'm gonna do is create a sketch on this plane, offset this by negative 2.4. Is that enough? Negative 1.2. Negative 1.6. 2. I'm going to cut this out. That way, if I have trouble pulling it out, I can take something that fits in there and push it out. Alright, so now what I'm going to do is I'm going to go ahead and mirror this. Mirror, 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 mirror. Mirror this body on plane 4. Bring out the tongs and see what it's going to look like. It still looks stupid. I could have brought them in a little further in. Let me see the other one. It looks more stupid, but so look, the other one is even further in and further out. So like, this is just honestly way better. Starting with a circle was a good idea. Okay, so then if I were to hold it like this, like I intend to do, then I've got, this one's the right side. Right, big scoop. And this one is left, big scoop. And I think that should work. I'm not going to add a lid to inside here because that just caused problems before. So hopefully I should be able to grab a significant chunk of French fries with this one because it is massive. If I take the this one and compare the size, look at the size difference. That is a massive size difference. I'm probably going to need to put support on underneath here when I print it. I wonder if I could print it on this plane. I would need support everywhere, but at least this would print better. I might look into that. It would start here and go, and this would have to go. It would start. Man, I'd need a lot of, so basically freaking everywhere this line is needs support versus the, oh, I might need less support if I print it there. Interesting, interesting. Another thing I can do, can I get away with this? I wonder if I can get away with this. Let me just get rid of this. Can I put a line from here to here? And extrude this to like it would be plane 11. And if I print that, and then I put a sketch here, I project this, nope, put a line from here to here, make it tangent, and extrude this to here. Now I've got these pointy bits that I have to work out. Or I could take and remove, what is this? If I suppress this, okay, if I suppress this, right, I can print this as that. I'm thinking about printability now. Because if I have this just like that, then this could be the plane that I print everything on, and then it won't need support until it'll need a little bit of support here. At least the program will want to support it there. But then how am I going to attach it? So I go into the very first sketch. Right? I would basically do that. And then what would that do? That changed to nothing. Okay. But it is pretty far out. But it is more printable that way, because now I can print it now I can print it standing this way. What? Trying to get a good look at the orientation here. Okay. Up. So I will now start a sketch here. Put a line here, 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 here. This is parallel to this. This is parallel to this. This is parallel to this. This is this is 15. This is 2.65. This is 2.65. This is 2.65. This is parallel. Oh, okay. This is parallel to this. And then that's 0.25. That's 0.25 and 0.25. Extrude this. Distance minus 20 plus 2 times 2.65. Minus. And I also have to now extrude that to here. Make a sketch here. Project it. Negative 2.4. Extrude that. Starting at an object. This one. Minus 2.4. Okie dokie. Then bring that sketch back because I'm gonna go ahead and extrude this to here. Can I move this mirror all the way to the end? Nope. I can move it everywhere but there, so I'll just delete it. Mirror. No, hang on. Take the tongs, disappear them. What happens if I try to put a sketch here? I offset it. And I extrude it. Lame. Yeah, that should be able to let me poke it out if I need to. Okay. So there's that. Now I have another idea that might be better than tongs. Because with tongs, a big problem was it's hard to reach into the basket, the fry basket. I mean, actually, with this angle here, I can reach into the fry basket fairly easily. But it's hard to reach into the fry basket with the big long tongs because they kind of just actually like that, and they kind of just get in the way, right? These will collide with the edge there. So I have another idea where it's basically these again, but just this, right? And it would be a clamshell. So I'm gonna mirror this across plane 4 before I forget. And then I'm gonna rename this to left big scoop. And I'm gonna save it here. And then before I print these, I will get started on the clamshell idea. I'm about to get started on making the this whole thing, but just this part. But I just realized why I wasn't getting the correct volume out of this circle. So where is it? Nope, it's way in the back. It would be in the 70s, right? Goodness gracious. No, is it in the 80s? Okay, this one. Alright, so what I did wrong was I was taking I was confusing the formula for the circumference of a circle with the formula for the area. So I need 6.667 inches, right, is the area. Divide that by pi. That's r squared. Take the square root of that. And then multiply that by 2. Now convert that into millimeters. .91. So like 74. So yeah, that's 75. Okay. That's fine. That's why the 50 some didn't work, but I had to like guesstimate 75. Anyways, just checking that this will be, yeah, okay. Alright, next I will get rid of the tongs, kind of. So I'm going to start a sketch here. I'm going to go back into these sketches and Find the sketch that's turned on and turn it off. Man, I've got so many sketches here that I need to really just start naming these. Oh, that's right. Hang on. There. Jeez. Can I move this? Ooh, I can move this. Anyways, project these. And project actually these. That's what I really need. Okay, and this is 57.223. Move this. Yeah, okay. That direction. That much. Move this. This direction. That much. Now they should be touching. So I need to widen this. I need to move them by that amount. And then yeah. So do the same thing to this one. Now they shouldn't be touching. So if I do this, I should be able to see through them. Yep. Now let's see. Let's see. Project this geometry here, and let's project this whole thing, and essentially I don't want to have to print this. I don't want to have to print these 2 times. So instead of making this as by itself and just attaching them and being able to, instead of having a separate like clamshell version of the thing, I'm going to make tinier tongs that turn it into a clamshell version. Put a point here. Put a line here. Put a point here. Line here. And a line here. Extend these lines all the way. Put a line in between these two, which I have to project. Bring this all the way over here. I don't know where I want to put the rotation point when I need to open these up. Ideally they would open up here, but then I'd have to redesign it and put a joint on them and do all that, but I don't feel like doing that. Well, I might be able to save a little bit of material if I do that. Hang on. Because if instead of making smaller tongs, I just put a... No, but then I have to open them myself. Put a point here. If I do this and I put a point here, that looks like a good spot. That looks like a good spot. Okay. Okay, these are equal. That's 5. 1.6. This is equal to that. This is equal to that. This one goes here. Okay. I need these all to be construction lines. Okay, and then that's a construction, that's a construction. I thought of a better way to do this. And then make these not construction. There. I could also... Oh, what did that... What in the world? Oh my goodness, what happened there? Oh, hang on. Okay. That's weird. Why is that moving? I don't know, but... It just occurred to me that putting that there isn't necessarily the best place to put that. Okay, let's see. Let me project these. 0.25, 0.25, 2.4, 0.25, over constrained. I don't know what it's perpendicular to, but good, I guess. If I just move this like here, and then I put a okay. Oh, the constraint has already been applied. Okay. And then that just looks pretty not stable. So what if I do this? That looks more stable. What is this? 4. I remember this would go up to here, and this would go up to the same. Oh, I think I know that's right. Okay. What if instead I just... I think that'll work, and then I'll just put a little Yeah. Ay, ay, ay. Okay. Alright, mirror all this stuff. Okie dokie, and now I can put figure to face at point. Point and face. There. Okay. Now I can rotate this. Let's try 15. That puts these close but not quite to parallel with each other. I kind of like that. That changes the that changes this though. And I think no matter what, that's always going to change that. So gonna go ahead and make that disappear. That is incorrect. I need to put the sketch here so that I can project all the stuff that I need to project. Four. 0.25. 0.25. Gonna eyeball another. Actually, I think I like that. And then 0.25, 5, 5. Alright, what is that? 4.1. Oh, that just changes this position. Alright. Gonna go ahead and mirror this, 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 this on this. Start offset 0.25, distance 20. So yeah, now these are teeny tiny tongs. And they might be a better angle anyways. But we'll see. Put a sketch here, put a line here, here, make these equal, and this is 2.4. All right. If I get plane 4, that goes straight through it. Mirror features. All right. Wrong drop down. Gonna rename this to Tiny Tongs. They're hardly even tongs, and I do not know if they will be able to bend as much as they need to. And if that's the case, then I can do one of two things. I can either just directly design these to have the joint in them, or easier, I can just redesign these. And if they if I'm gonna go ahead and make these one at a, or all at once, let me think about the easiest way to hold them. I might want to put like some kind of grip feature on these, because they're probably going to be pretty big and chunky. Because if they're 75, if it's a 75mm circle, right, it's already there. And then I've essentially got two, so that's 150. So I can barely hold them. And then it comes out a little farther. Can't even grab them. And that's the advantage of the actual tongs. Is that the actual tongs will allow me to have something to grab. I wonder what happens if I change this angle. Too much bad stuff happens. Okay. Well, I'm gonna go ahead now and export all these meshes, and then I'll have them printed and see what happens. So save as mesh, preview 4192. Right big scoop, save. Left big scoop, save as mesh. Preview 4192. Save. Tiny tongs, save as mesh. Preview 4192. Nah, it's 560. Save. Alright. Now I'll get these printed out and see how well they work. Hopefully well enough to actually use. Probably not, though. I think if these don't work out, I'm going to have to just give up on this project. But so far the biggest issue, so far the these worked somewhat well. This worked more well, or better, right? Then this one worked the best so far, and it just didn't have enough volume in it. So these ought to be pretty good. So I'm going to save here, and I'm going to go get these printed and see how it works. Okay. So before I even test these, I printed out these and this, and I found two issues already just by taking them off the build plate. One is I designed this ever so slightly wrong. It works, at least it should still work. It should still work, but I think I did it wrong. Where's this mirror? Okay, so what I'm gonna do is I'm just gonna oof, I don't like what I've done here. Okay, so what I'm gonna do is I'm gonna go ahead and start a sketch here and fix what I did wrong on this. At least attempt to fix it. And it should still work with the mistake. I just don't like it as it is. And so I'm gonna go ahead and try to fix it. I'm not gonna print this. I'm not gonna print this unless I absolutely have to, though. Right? This is just a hypothetical. So what I did wrong, right? Was making these right? Yeah, what I did wrong was making this the 0.8 instead of it making it perpendicular to this, actually. Okay, and then this is 0.8. And then put a line here that is going to be parallel, and then put this on this. Okay. Now I'm gonna go ahead and put this line where it needs to go. And I'm going to do the same thing on this side. Put that there. Then I'm going to extrude this to here. I wish I could just shave that off. Can I? Circle. Cannot complete extrusion. The extrusion profile falls outside the boundary. Okay, how far outside? It's like just barely. Okay, well, because that didn't really work the way I wanted it to, I'm probably going to have to just recreate it from scratch or just go back to the original sketch and redo everything from that point. Because I would have to change the first extrusion, then the next thing that was based off of that, the next thing. So, because I don't feel like doing that right now, I'm going to go on to the more pressing issue, which is that these are kind of a little bit too close together. If I were to rotate this on this axis, that happens too far away. It's kind of annoying because I know how far away it should be. It should be about here. Or something. Right, hang on, let me see. Anyways, I gotta do two things. I gotta make this longer and add more. It's not stiff enough, or it's too stiff, and add more little wavies to it. So where is that's the extrusion. Here's the sketch. Minus 20 degrees. So this is the okay. And then this sketch should be based off of where this is. Okay, good. Okay, and then it was this extrude. Oh, I gotta add two whole circles on each side, huh? I don't feel like doing that. So I'm just gonna go ahead and alright, so that'll go there. What if I did this? I could do it that way, yeah. Oh, but I still would have to add the circles. So I'll just add the circles. Well, let me change these to 1.2. That'll make them less stiff. And I believe this was like a 1/4 millimeter. I'm gonna make that like 1 millimeter. Okay, yeah. Okay. And then this one.
Hey Joel,
Hang on.
I was just curious where you're at.
Oh, I'm in my room.
Hey Joel, actually I have a question.
And
Is
that
egg and sausage thing in the fridge open to being used or no? Is that just for you?
hang on a minute. I'm almost done. Okay, so I'm gonna print this now. I'm gonna print this, and then I'm gonna have to redesign this from scratch if I want to change it. But I'm not gonna I mean, I might want to change it, but what I've printed should work for at least testing purposes. So, tiny tongs, save as mesh. Save, yes. Alright, so now I'm going to get this printed out, and then I should be able to test things properly. Because I believe, I mean, I could just check real quick. That's closer. I'm hoping that this will give just enough to like curve around so that these can become more or less parallel. Anyways, I'm gonna print this, so we'll see. I've got all the things I needed to print out. A basket of fries, the tongs. This was the original tiny tongs design. It is not flexible enough, so I had to change it. This one is flexible enough. And I guess I'm gonna start with the tongs. And the thing that I have to do here is I'm gonna have to wrap a piece of paper around these, because the blue filament is a much higher quality filament than the clear filament, and so I get better dimensional accuracy, which means a 1/4 millimeter is too loose, so it has to stay on. So I need a piece of paper in between to keep it on. Now I'll test it out. I'm going to test it this way. I'm going to try this. Push them all up. They still want to come out. Let me see if I can shake them out. Well, I can hold a lot. Jeez. If I hold it up. How much did I get? The clear one came out. I got a lot in there. They're pretty soft. I think one thing to do to fix that issue of them wanting to get stuck like that is have the contact be very small between these and put a little hole in them, right? So that'll probably help. Another thing I can do is on the side that this is on, is hold it up against the so these want to come off. I'm gonna try it with the clamshell, with the tiny ones. All right. And I should push these in a little more. And that's close enough. And now I'm gonna see if it's gonna be easier to scoop them. I gotta get underneath. Again, a fry basket is not a good surface, but if I can get underneath them, right, then I've got a good chunk of fries there that I just put into the thing. So actually, the clamshell idea does work better than tongs. So I'm sticking with the clamshell then. Looks like the next thing to do is to fix the issue, fix two issues. This is paper thin here. I don't want it to be paper thin. I want it to have some significant thickness so that it doesn't get bent and damaged as easily. But around the edges here, just leave a little bit of space around the edges so that so that it won't squish the fries, and whatever fries end up in between these bits, right, will either fall out or fall into the thing, which means I can also add back in the plate at the bottom here, if I do that, because then I'll just at that edge just put a little cutout so that it won't squish the fries. And then what I can do is I can grab it, kind of shake it like this to shake them in, and then also this fits in here. This should be bigger. This should be bigger, and the reason it should be bigger is I got some popcorn chicken. I tested this earlier. Got a piece of popcorn chicken here. It doesn't go through. So I need to make it so that I can go through with this piece of popcorn chicken. So yeah, now I'm gonna eat these fries. I'm gonna prepare some more fries because I have time today to do that. I'm gonna eat these fries, prepare some more fries for further testing, further experiments on this, and I'm gonna go ahead and make the changes that I wanted to make. And I might as well change the tolerance here to be in line with this filament now, because I ran out of the clear, so I had to print it in blue. And the blue is a far better quality, so I get better accuracy. Like, the same snugness of a 1/4 millimeter difference here, or to get this, so for a 1/4 millimeter gap here, to get that same amount of snugness, you need something like 1/10 of a millimeter, between 1/10 of a millimeter and 0.2 millimeters, so like 0.15, and that'll be roughly the same snugness. So yeah, and even then it might even be a little bit loose. So yeah, I'm gonna continue with this one though. Look at the, I don't want to gamble on my next design being the very final design, but it very well might be. And because I want to stick with the clamshell, but see, the thing is, because this is so big, it doesn't fit in my hand very easily. So having this here makes a good, having this part here, which was for the tongs, right, makes a very good handhold, right, where I can put my hands. So I think I'm gonna keep the design like this, because because to be able to put this directly on this, I'd put it around here, and it'd have to open like this far, and if it opened that far, I just wouldn't be able to grab it. So I'm gonna make those changes.